students in a class plays at least one of squash, hockey, and tennis. So let's make a Venn diagram. So 18 students play squash, 19 play hockey, 17 play tennis, 8 play squash and hockey, 9 play hockey and tennis, and then 11 play squash and tennis. Whenever you do the Venn diagram, you always want to start in the middle, but here the middle is not given to us, so we're going to call that X. And then we're going to work outside. So start in the middle, then work your way outside. So let's work in the intersections. Squash and hockey is 8. So far we have X, so there's 8 minus X remaining. For hockey and tennis, we need 9, so this has to be 9 minus X. And then for squash and tennis, we need 11, so this has to be 11 minus X. Then we move on to squash, has to be 18. So we need to subtract 8 minus X, X, and 11 minus X to get the remaining here. Well, 8 minus X plus X is 8, and then we'll subtract 18 minus 8, and then minus 11 minus X. So this will be X minus 1. For hockey, you want this to be 9, or 19. Here you have X plus 9 minus X is 9. 19 minus 9 is 10. So you need 10 minus 8 minus X, which will be X plus 2 over here. And then finally for tennis, there's 17. We have 11 minus X plus X is 11. 17 minus 11 is 6. So X has to be, so there has to be 3 left, so X minus 3. Now, we're given that there's 30 students, so if I was to add all of these, I should get 30. So the easiest way to do this is to have a column for X's and a column for the constant. So I'm going to start outside, X minus 1, X plus 2, X minus 3, and then I could just do 11 minus X plus X is 11, and then I have 8 minus X and 9 minus X. So that'll be negative X plus 8, negative X plus 9. We have 2 negative X's. That's going to cancel out with the 2 positive X's. Negative 1 plus 2 is 1, minus 3 is negative 2, plus 11 is 9, plus 8 is 17, plus 9 is 26. So you have X plus 26, and this has to equal the 30 students, which means X has to be 4. So now we can go back in the Venn diagram and plug in what we know. So let's make a new one. So when we plug it in, we get 3, 4, 4, 7, 6, 5, and 1. And so now we can answer some questions. The first question is, find the number of students who play all 3 sports. Well, all 3 sports is going to be in the middle. That's going to be 4. Next question. A student is picked at random from a class. Given that this student plays squash, find the probability that the student does not play hockey. So we can write this as probability they do not play hockey given they play squash. So this is same thing as probability they do not play hockey and they play squash over probability they play squash. So the probability they do not play hockey and squash. So let's see. So squash is going to be in the red here, but we do not want to have them play hockey. So we got to get rid of these 2. So that has that gives us 3 plus 7 remaining. So let's write that down. Over the probability to play squash, well, how many play squash? It's 3 plus 7 plus 4 plus 4. That's going to be 10 over 18, which is 5 over 9. Now finally, we want the probability, there's two different students are picked at random from the class, one after the other, without replacement. Given that the first student plays squash, find the probability that the second student plays hockey. For this one, there's going to be two cases. Either the first person plays hockey as well as squash, or they don't play hockey. So we can represent this. Probability second person plays hockey given the first person plays squash, as a probability the first person plays hockey given the first person plays squash times probability the second person plays hockey given the first person plays hockey and squash. Plus, now you want to do the complement, so this time the first person does not play hockey given he plays squash times the probability the second person plays hockey given the first person does not play squash and he plays he does not play hockey and he plays squash. Okay, so let's look at probability. He plays hockey given he plays squash. So that's going to be the intersection over probability he plays squash. And if you want, we can just look at the top here. So hockey and squash is the 4 and the 4. That's 8. Given that he plays squash, that's going to be the 18. So it's 8 over 18, which is 4 over 9. Now we want to see the probability the second person plays hockey given the probability the first person plays hockey and squash. So we go up to the Venn diagram. Now there's going to be one less person here because we don't replace that person. So instead of 30 people, there's going to be 29 left. And then instead of having 4 plus 6 plus 4 plus 5 people playing hockey, in other words, that's going to be 19 playing hockey. There's going to be 18 remaining that play hockey out of the total 29. So that goes over here. And then the probability the first person does not play hockey given that the first person plays squash. We could just use a Venn diagram for that. Or you could just say that's the complement of this one right here, which is 5 9ths. And then we look at the probability the second person plays hockey given the first person does not play hockey but plays squash. So we have to look at the Venn diagram. Because the first person doesn't play hockey, there's still going to be 19 people left that play hockey, but because the first person went, we don't replace the first person, there's going to be 29 people left. So there's going to be 19 over 29. And so when we simplify this, we have 4 9s times 18 over 29 plus 5 9s times 18 over 29. And that simplifies to 167 over 261 as our final answer.